Today we are going to see the longest substring problem without repeated characters in Leetcode. So given a string S, find the length of the longest substring without duplicate characters. So if the input is ABC, ABC, BB, we have to return 3. It means the unique substring character here is ABC or BCA or CAB. So we have three unique substrings, but all three are having length of same. So we just need to return the max length, which is B, which is 3. And the example 2, all are B. So the maximum substring here is only a single character B, and we are returning output 1. And for the example 3, the longest substring here is WKE, and that's why the output should be 3. And the constraints here are the length of the string can be between 0 and 5 into 10 to the power of 4. So the length can be 0 also, and S consists of English letters, digits, symbols and spaces. We are going to use sliding window and hash map to solve this problem. Sliding window, we are going to keep the unique substring inside the sliding window, and the hash map we are going to use it for searching. I will explain this when we are doing the dry run. Let's take the first example, ABC, ABC, BB. We start with the left pointer at A, and we will update the max length as 1 because A is a single character which is unique. We can keep it as 1 for now. And let's go to right pointer to B. I'm going to keep the right pointer at the top and the left pointer is going to be at the bottom. And this substring is unique. Currently this is a substring A and B. This is unique and the length is 2, which is greater than the max length, which is 1. So we can update the max length to 2. Now we can go to the next character. The right pointer is moving from B to C. So this is the substring now. This is unique and it is having 3 characters. We can update the max length to 3. So you can move the right pointer from C to A. At this point we have duplicate. So now the substring inside the sliding window between the left pointer to the right pointer is not unique because there is a duplicate character A here and here. So we should not account it for the max length. When we account a duplicate in the sliding window, that is the time we have to move the left pointer. And where to move the left pointer? We have to move the left pointer to the next character after the duplicate character. So the duplicate character here is A, and we have to move the left pointer from next character to A, which is B. Now the sliding window is this, from B, C, A, and this is unique. When the characters in the sliding window is unique, we are happy. So we can move the right pointer again. It is going here. Now again we are seeing a duplicate. The B and the B are duplicate. When we encounter a duplicate character into the sliding window, we have to move to the next character. So we are not simply incrementing the left pointer. We are moving the left pointer to the next character of the duplicate character. So the duplicate character here is B. So we have to move to the next character, which is C. Now sliding into CAB, which is unique, and we keep moving. Right pointer coming to C. So again the duplicate comes into picture. C is duplicate. We have to move the left pointer of the sliding window to the next character of C. It came here. So length is again 3 only, so we are not updating the max length. Moving forward, moving the right pointer to B. Now again we encountered a duplicate character. This is duplicate with this one. So far we were moving the left pointer just by 1. It was previously at here. From here it went here. Then it went there. Like one character we were moving. Actually we are not simply moving the left pointer. What we are doing is we took the index of the duplicate character into the sliding window and moved the left pointer to the character next to the index. So in this case, the left pointer should move from here to here, because the position of duplicate character is this one, and the left pointer should always go to the next character of the duplicate character. It should go from here to here. So to move the left pointer to the character next to B, we should know the index of the B. So we know the old left pointer which is at A, and to identify the B's position we can traverse, but that is not efficient. Instead of that, we can have a hash map to store every index. Let's try with the hash map, starting with the left pointer at here and right pointer at here. For now let's keep max length as 2, and this is our hash map. The hash map for now, in the sliding window we are having character A, the index is 0, and character B, the index is 1, and we are moving the right pointer. Now it is still unique, there are no duplicate characters, we don't need to update the left pointer. But when we are having a new character coming into the sliding window or coming into the unique character, we have to add that to the hash map. So C is getting entered here with the value 2, because 2 is the index. We are moving the right pointer again. Now we got a duplicate. So how to find a duplicate? We don't need to traverse the entire sub pointer. We can simply check in the hash map. We can see whether A is there in hash or not. If A is there. If A is there in the hash map, we can simply say that the substring is not unique. It means there's a duplicate. When we encounter a duplicate, we have to update the left pointer to the next character of the duplicate character. So the duplicate character is A and its index is 0. So the new left pointer will be 0 plus 1, which is nothing but 1. So the left pointer is moving from here to here. Now the updated substring will be BCA, which is unique. And when the new character is added into the substring, we have to add its key. We have to add its value into this hash map, right? So we are entering A into the value of 3, but we have moved the previous A, right? We have moved the previous A out of the substring, so that should not be there in the hash map. So whichever character which are removed from the substring should be removed from the hash map also, because this hash map is a hash map of the substring. It is holding the characters, those are only in the substring. It is not having a hash map of the entire list. It is a hash map of only the substring. The substring is going to be unique, and all the characters in the hash map are only from the substring. So every time the sliding window is moving, the right pointer is moving forward or the left pointer is moving forward, it is leaving some characters behind. Those characters has to be removed from the hash map. So moving forward, we are moving from right pointer from here to here. So again there is a duplicate. This B is duplicating from here. But how are you checking duplicate? We are coming and seeing in the hash map. Is B here? Yes, B is here. And the formula for updating left pointer is the index of B plus 1, which is 2. So left pointer is moving from here to here. It is leaving this B out of the substring, so it has to be removed from the hash map. We are removing the hash B from the hash map, and this B is coming into picture, so we are adding that into the hash map. So B and its index is 4. Now moving on, right pointer is going from B to C. Once again duplicate. We are checking here, is C present here? Yes, C present here, and its index is 2. Update the left pointer equal to 2 plus 1. Left pointer is moving to 3. Left pointer is going from 2 to 3, and this character is moved out of the substring. We have to remove that from the hash map, and this character is entering into that. We have to add that into the hash map. So C and its value is 5. And moving the right pointer from here to here, is B present here? Yes, B present, and b's index is 4, so the value is 4 plus 1 equal to 5, and left pointer is going, currently it is at 0 1 2 3, it is moving from 3 to 5. We are not going just one character forward, we are directly moving from 3 to 5 directly. So now we have to see these two characters A and B went out of substring. These are not part of substring, so it means we should not keep them in the hash map also. We have to remove A as well as B. So this is the new right pointer, this is a new left pointer, and this is the new substring. We should have these two here. C is already there, and we are adding B into the hash map. B, its value is 6. Now once again moving forward, this right pointer is going from here to here. Is there a duplicate? We are checking in the hash map. Yes, there's a duplicate. The index is 6. Left pointer is updated from 6 plus 1, which is 7. So left pointer is going from 3, 4, 5, 6, 7. Left pointer is moving to here. And this time again we left these two characters out of substring, and we have to remove them from the hash map. So both C and B with index 6 will be removed. Instead, B with index 7 will be added into the hash map. But we have reached the end of the substring, so we are not moving forward. And updated max length is 3, and we are going to return this. If S is an empty string, there are no characters, simply return 0. Otherwise, let's set the global variables. LPTR start with 0. Let's set the substring hash map. It is going to be an empty dictionary. Currently we are going to put only the character at the left pointer. And the index is going to be 0 for this one. And let's start with R pointer at 1. And we are going to traverse the entire string until the right pointer reaches the end of the string. So we are going to have a while loop until R pointer is less than length of the string. So to identify whether there is a duplicate in substring, the substring currently is between the L pointer and the R pointer. Now we have to see whether the character at the R pointer is already there in the substring hash map. If it is there, there is a duplicate. When there is a duplicate, we have to update the L pointer. So the new updated value should be the index of the duplicate character plus 1, and we need to remove all the characters between the old left pointer to the current left pointer from the substring hash map. So for that we need the old L pointer. Let's remove all the characters from the substring hash map. All the characters that were removed from the substring hash map. Now we have to add the newly added R pointer character into the substring hash map. The index is updated for the duplicate character. For every case, even there is a duplicate or not duplicate, we have to check whether the substring length is more than the max length. We have to update. Like initially, we didn't set the max length. Let's set the max length here to 1. Because currently the unique character is the first character, and the first character, the substring with one character length is 1. We are setting that as the max length. And here we are going to check every time if the substring length is bigger than, it is greater than the max length, we are going to update the max length. and we are going to compare the substring length with the max length. If so, let's update the max length. The value at the R pointer should be added into the substring. So we are doing that once inside the if, but anyway we are doing it outside also. We can simply remove once we are doing what we are doing inside the if, because it is getting updated here for common for both of the cases. I think this code will work. Let's return max length from here. Let's try with the given test cases. Actually, we forgot to increment the R pointer. Let's increment here. Let's rerun that. We have bad output. Output it says 8. Why it says 8? So substring length is always R pointer. Okay. L pointer is updated. Old L pointer is there. Deleting. This is the mistake. We are checking the R pointer in the substring hash map. Actually, we have to check the character at the R pointer into substring hash map, not the R pointer. We should check yes of R pointer. So here also it should be yes of R pointer. The character at the R pointer, we are not going to use the index as the key. The character at the index is going to be the key. So wherever here is substring hash map, we need to put that correct value. So here it is proper. Here also it is proper. Let's run this code. Substring hash map is not defined, so it should be a str, not string. Okay, all the 4 test cases are successful. Let's submit the code and see. Yes, our code is accepted. All 988 test cases are passed. And let me know your thoughts in the comments as well. If you have any doubts, please let me know in the comments. I'm happy to answer. Thank you.